Here's Mushtaq. Okay, authentication. It's quite a big topic, and there's loads and loads and loads of stuff out there regarding kind of best practices, and lots of people have lots of opinions about the best way to store the data and authenticate your users and build this functionality of creating accounts and logging into your apps. There is loads out there. Today I'm going to show you one way to do it. It's not the only way, but it is it covers quite a few bases, and it's one of the sort of easiest to follow. But it is fairly chunky. So authentication, by authentication, we are referring to allowing users to log in, to authenticate themselves with the server, to say, I am the user Sam, and I should have access to these particular pages and this particular data. So these are the four sort of steps that we're going to do today. We're going to allow our users to create an account. We're then going to allow our users to log in. We'll store passwords securely. So, and that's actually not really true, because we're going to do it in like a file so we can see stuff. But we aren't going to store them in plain text. And we are going to remember the user. So when our user comes back to the website, they don't have to log in again. The browser remembers, sorry, I've started already. The browser remembers exactly who it is, and the server says, yeah, that's valid. I will allow you to access the website without putting your password in. So, salting and hashing. This is to do with how data gets stored in a secure method. So, in this example, we have a password, we have some kind of string, in this case it's password 123, plus a salt, which is salt ABC, and the two combine to create this string, password 123 salt ABC. So when you type in your password onto a website, a securely built website, it doesn't just store password 123 in a table. It combines it with some other unique data so that it's much harder to guess, it's much harder to crack, it's not just stored for anyone to see in the database. So one interesting thing about salts and the way they work is they change every time. So we've just used the salt ABC, and the next time we create a new user, we're going to use salt DEF. So every single time this salt changes. So your password that you type in plus a unique salt means that we're very securely storing this password, and it's not visible to our user. This is obviously a very simplified version. It's not just adding one string and the next string together. But the idea is the same. It takes your string, it combines it with some other data, and then runs it through an encryption algorithm to result in a bunch of random, seemingly random characters. So bcrypt is a pretty common hashing algorithm, and we're going to use bcrypt in our server. There's loads of others out there if you don't want to use bcrypt for whatever reason. Bcrypt is the standard in Ruby on Rails servers. It's pretty standard. There are others out there, but bcrypt's been around for a very long time. It's very hard to crack because it's deliberately slow. Actually, it's kind of weird. It's weird that way. But it's very secure. It's kind of stood the test of time. So we're going to use bcrypt. So we've installed the bcrypt module. We require that module. And then here, this bcrypt module that we're using, we can specify a number of salt rounds. So that means every time we create a hash based on a user's password, we're actually running through 10 different salts. So where previously we had salt ABC and then salt DEF, it actually goes through a new salt 10 times before it generates the hash. So it's, I mean, arguably the higher number the better, but it's, like I said, it's deliberately slow. So you don't really want to just chuck on a million salt rounds every time a user wants to sign up, because that will be very slow. But it's an extra little bit of security. So we call bcrypt.hash. Bcrypt is a hashing algorithm. To hash means kind of to take data in one form and usually generate a string of characters that represents that data in some format. So bcrypt.hash is the function. The first argument is the string that we want to test against, that ultimately we want to store in our database. We want to store password 123 in our database, but we don't want to store it like that. Second argument is the number of salt rounds. Third argument is a callback. And as you should be fairly familiar now with lots of node libraries love a callback, and the first argument is very often an error. So if something's gone wrong, then we can handle it. Otherwise, we are going to receive that hash and we're going to store that in our database. We're not going to store password 123. We're going to store the hash only. Then when the user logs in, so this first step is when the user signs up. So we are creating a new hash to store in a database in our users table. We've got a users table, we create a row with their email address and their password, but actually it's going to be a hashed password. This compare, this is going to be when the user logs in. So the user types in their password, clicks login, the browser is going to send the password through to the server. The server then compares, well, first actually, the server goes and finds the record in the database that has the same email. So if you get your email correct, it's going to find the record in the database for you. It's going to get the hash from the database, so that's going to be sort of user.password hash or something like that. And we're going to compare, is the password that they've just typed in, password 123, is that the same as the hash that we've stored in our database? And it won't actually be the same, but Bcrypt is going to run this through a hashing algorithm and run this through a sort of unhashing algorithm, and if the results are the same, then we can say, okay, good, you've logged in, you've typed in the password correctly. So we're going to build a server. I realised fairly late on when I was planning this that this comes before the kind of more recent students have done front-end requests and responses. So today's lesson, there is going to be some front-end. Don't worry too much about the front-end for now, but we're going to build the front-end. I won't really explain things about fetch or anything like that because that will come in a few weeks. Yeah, there will be some front-end stuff using fetch, which you may not know yet. Okay, so as always, npm init-y, we want to start a new project. Npm install express and bcrypt. So in index.js, we are going to have index.js, okay, bcrypt.express. Okay, so express is require express. Bcrypt is require bcrypt. So for now, let's actually just kind of play around with bcrypt and let's log out some of these hashes. So console log, no, not in there. Salt rounds. Let's do salt rounds 10. Let's play around with salt rounds. So bcrypt dot hash. Let's use password 123. Salt rounds and then error and the hash. If there's an error, we just want to console.error, error, else, something like that. So node mon index. Okay, so that is our hash. Let's add in the word hash because it doesn't really look very friendly. So $2b, $10, blah, blah, blah. So it looks fairly similar, but it's not the same. We've written password 123. It has hashed it and salted it with 10 different salts to generate this unique hash. So if the next user signs up and uses the same password, password 123, it means the same data isn't stored in the users table for both of those different users. So a user couldn't just kind of guess a common password that lots of users might have and hack into their accounts. The salt makes it unique every time. Let's see what happens with salt rounds 1. Really kind of nothing, we can't really see any difference. This one is different to this one. So really it's kind of the same. Let's see what happens with salt rounds 0. No, it's always salting. The salt is always changing. So salt round 0 isn't. We're not really allowed to do that. Salt rounds and then salt rounds 10. That's kind of best practice. That's by default. That's what the Bcrypt library recommends. So we've got Bcrypt hash, and now we want to do Bcrypt. What was the other one? Compare. And here, password 123. We can take one of these. Result. If error, did I say error? No. Oh, I did a dot. If error console dot error else console dot log result true. So what's that say? What that is saying is this hashed string, this encrypted data, does contain password 123, or not really does contain, but this string was originally generated using password 123 as the sort of seed data. That's kind of what this is saying. So if we change it to password 124, we're going to get false. If we change this to 123 and just add an A to the end of that, that's going to be false. So if our users mistype their password, if for some reason our database messes up and the data that we're storing in our hashes, if that changes, then our users won't be able to log in. But I feel like I've shown you this before. Have I been pwned? If samuel.e.barker@gmail.com, that's my email address. Oh no, I've been pwned. Breached on one site. Wattpad, I don't even know what that is. This incident exposed extensive personal information, including all of this stuff, stored as Bcrypt hashes. So at least these are hashed. I actually use both Gmail and Google Mail, so I think I have been in more breaches with Google Mail. And here, half of them SHA1, half of them Bcrypt. Salted SHA1 hashes of passwords, unsalted MD5 hashes, so that's bad. So MD5 online, you basically go password 123 and then decryption found, but it's a blacklisted word. What? Oh, they make us pay for it. That's annoying. But basically, you can just figure it out by running it through an MD5 algorithm pretty easily. I'm trying to look for one that says plain text text. Oh, text. I thought I was involved in a breach that uses plain text. Clearly not. But what you don't want to find on here is when you type in your password that it says email addresses stored as plain text. That just means that the database is just storing this string. So now if you build a server and your server gets compromised and all of your data gets stolen, at least you can be safe in the knowledge that it is using bcrypt to hash all of the passwords. Okay, so let's now build the server. So we want app is express dot, do we just call express? I always forget how to set this up. Create an express application, yes. And then at the bottom we do app.start. Or listen, yeah, okay. Callback. Isn't it a port and then a callback? Yeah. It's the type of thing that you do once on a project and then never again. Listening on 3000. Okay, listening on 3000, that looks good. So we've got our Express server running. Let's just have a test of app.get request response. Response.send hi. Okay, that's all good. We're getting hi back. So in here, we're going to build out a form a bit later on. We're going to build out a page, or we'll serve a static page or something. But for now, let's just worry about the sign up and login post requests. So our users are going to click a button on a form. It's going to post some data to sign up. So request response, and what we're going to do, so this is where for those of you who haven't done the other modules yet, this is where we're going to write a fetch request. So method, we're going to make a post request, headers, we're going to have our content type, it's going to be JSON, we're going to send JSON and accept application JSON as well. And our body is going to be a stringify, username Sam, password Sam1, password confirmation Sam1. Then we close that. Okay. We can see our network request. It's still pending because our server doesn't have anything in here. So let's just say status 404.send. For now, let's do that. So we haven't implemented our route on our server yet, so we are responding with a 404 back to the client. So in here, we want to create a hash of that password. So we can call bcrypt hash, and instead of password 123, we can get the password out of the body. So request.body.password, that's going to work. And then console log, instead of console log, response.status 500, send error, response status 200, send hash. Okay, so I'm going to send that again. We get a 500, and that's because it just completely broke. Cannot read property password of undefined. Request dot. Do we need to use body parser? Yes, I think we do. App.use express.json. Okay. So now our request was successful. We've got a 200 status code, and our response includes our hash. You don't want to do this. You don't want to send the hash back to the user. Okay, it's still pretty secure, it's salted and all of that stuff, it's encrypted nicely, but this is not what you want to send to the user. What you do send is something probably that represents the user. So probably you're going to send an object that is kind of the row in the users table that includes the user's email address, so you can, or their first name, so you can in your front end say hello first name, and you might include their posts or their I don't know, something that they might want to view after they have signed in, but you don't want to send this hashed password back. So if it's all good, we send, I don't know, user request.body.username, and now we're responding with a nice, useful JSON object. So that's hashing. That's hashing on sign up. So I'm going to store this in some kind of text file or something, passwords.txt, which is clearly not what you should be doing, but it's nice and simple, passwords.txt. So we're going to, I don't know, db.js, which is clearly not a DB. We're going to create a function in here called add new user, which is going to take a JSON user, which is going to be a string, which is going to be an object, and we're going to stringify it, user string, JSON stringify, JSON user, and then we're going to add it as a new line to the end of our passwords.txt, or let's call it db.txt. Okay, so we want file system, require fs, and fs.write file, or we want to, I've forgotten how to do adding a new line. Can I do it off the top of my head? Write line, something like that. fs.write line, no, write file, replacing the file if it already exists. So we're going to write db.text. The data is going to be user string for now, just as we're testing. And I like promises, so let's have promises. File system promises, write file. Oh, actually, no, we're not doing promises yet, are we? Because not all of you know about promises, I don't think. So write file, then callback, error, if error, console, error, and return. Otherwise, we can add new user, we can success callback. So down here, add new user. So we are going to say db equals require my db file. Then down here, we're gonna else db.add new user request.body is the object that represents our user, and the second argument is the callback on success. So that's where we send our object back. So let's have a look. Sign up, user Sam, that's all good. Let's look at db.text. Username Sam, password Sam1, password confirmation Sam1. So, even though we are, or we think we are successfully hashing that password, we're actually just sending the raw data through. So we don't want to do that. Username is request.body.username, and password hash is going to be that hash. So now if we do it again, we can see we've stored a username key and a password hash key as well. So this is, okay, yes, it's just a text file, this is stupid, but if this was a row in a users table, then we would be storing our password hashes securely. Okay, so our database is adding a new user. It's actually just writing every single time. So let's do something a little bit different. Let's read file db.text encoding UTF-8 probably. Then error data, then write file, the data with a new line, and no, that's a new line, and whoops, the user string. Let's see if that works. Great, we've got two in there. They actually have the same username. Probably they have used the same password. In fact, we know that they've used the same password, but with our bcrypt salt, it has saved a different hash each time. So in index, before we do all of this, we actually want to do some validation of that user. So we certainly want to do if request.body.password doesn't equal request.body.password confirmation, then we just return early and response.status 403, something like that, send oops, your passwords must match. So now password confirmation sound 2 and 403 forbidden. Now that's not really the correct status, but we are responding with an error and the details saying oops, your passwords must match. So we'd also probably want to do if username already exists, we want our users to be all unique. You'd do something like if it's an email, if email is valid, so if it contains an @ symbol and a top level domain and all sorts of things. And you can run all sorts of validation depending on the data that you're storing in your database. Okay, so that's signing up. Signing up and validating that we will allow that user to sign up. We now want to do the same for login. App.post to login. We have our request and our response. Then, so we take our password from our request.body.password. Actually, we're going to take our user, what have I called it? I've called it username in here. Username, and username Sam in there, okay. So first we want to find user record with username, compare password with password hash. So let's go to our database, get user, it's going to be a function, get user, username. So we could read file and get user. I'm going to use the sync version because I can't be bothered with callbacks. So read file sync file data, then records or rows in a table is going to be file data dot split by new line. Then return rows dot find the row that includes username This is pretty dodgy, but it's very quick and dirty. It's easy to see this data. So this is not how you should be building a production database, but this is pretty much how you should be using Bcrypt and storing your data and allowing users to sign up and log in. It's only how we're storing it is the no-no. So now we've got get user, db.get user, user is, and actually we want to user row is that if no user row, return null, otherwise return json.parse user row. So we're going to give it a username string, and we're going to receive a parsed stringified JSON object back. So we're going to get a JavaScript object. So we pass it that username. We're going to have this user dot, what did I call it, password hash. So we want compare the password that the user sent with the form with user.password hash, and then we handle the error and the result in here. So again, result if console error, no, I can't copy that. If error, response.status 403, probably send wrong credentials. And also if no user, we do the same thing. And we have an early return because we don't even want to get down to comparing bcrypt. We already know that user doesn't exist. We compare the password, else we can set the status of 200 and something. Status codes, I'm sure there is one for sort of something kind of a successful form rather than just success. So successful response is 200 to, yeah, 202, that'll do. 202, and actually 201 created, that's what we should have done in here. We've added a new user, we've created it successfully, and then here the request has been received but not yet acted upon. That's a bit of an odd one, but never mind. Okay, response status 202, and send for JSON, we're going to send the user object. Okay, so we post to login, we get the username and password out just for easy access. We find the user record in our database with that username. If that user doesn't exist, we already know, okay, you've done something wrong. If that user does exist, we're going to compare their password that they've typed in with the hashed version of the password in our table. I've done this wrong. If there's an error, then send some wrong credentials error back. Otherwise always send the user back. But actually, we only want if result is true. If the password does match the password hash, if result, then send this, else we'll send the same thing. Okay, so that should work. So instead of sign up, we're going to post to login. Username Sam, password Sam1. Why has it appeared at the top? Okay, it's right. Okay, here we go. Username Sam, password hash. Again, we don't want to include the password hash. So we're currently just sending the raw data, 202 accepted, the username and password were sent in our form, and we're getting the raw data back. We don't really want to do that. So maybe in our database, we, what could we do? We could spread out that user object, then say password hash is undefined. Is that going to get rid of it? I can't quite remember. Uh-oh, 403 forbidden. What's happened now? And why isn't this appearing in my network? Time. Okay, wrong credentials. I've done something wrong. So let's see where it's going wrong. Wrong username, wrong password, and wrong everything. So we've got wrong everything. So the password that we're comparing doesn't match the hashed password in our table. So let's log it out, password and user.password hash. Sam1 and undefined. Okay, great. Oh, I know. That last thing that I just did has messed this up. Username Sam and password hash undefined. So here we do want to keep the password hash, but in here we don't want to send it back to our user. And I thought undefined means it's not going to show up in the body. Let's see what happens. Okay, great, it did work. So now username Sam and our password hash undefined doesn't show up in the body of the response. Okay, so we have sign up, we have login. It's all happening through the console at the moment. It's 7:05. I think I'm going to move on to no, I think I will do the front end now. At the moment, does anyone have any questions on signing up and logging in using salting and hashing algorithms, anything like that? So next I'm going to build the front end. We're going to have a form that allows the user to sign up or log in.
Sam, it's not a question. It's like I didn't know that in our browser we can do fetch, like we just mock fashion, right? We don't use front end, and we just use the console to fetch the URL.
Yeah, I find it really helpful. I know a lot of people use Postman. I don't tend to use Postman. If I'm working on a server, I will probably just open a page like I have done here and just write it in the console. Your console is just a place to execute JavaScript, just like when your HTML file downloads a JavaScript file and then executes it. It's exactly the same. So anything that you would write in a JavaScript file would work in your console. So it's pretty useful.
Yeah.
Okay, so if there's no questions, we're now gonna build a very, very small front end. We're going to have a static folder, index HTML, HTML5, site account users, etc. Something like that. We're going to have a form post. The action is going to be sign up, and we're going to have input. I know Vasile says to use Emmet, but I've never got used to that. So input type text. Here we're going to have password, and password confirmation. Input type submit, ID submit. And so we're going to have login. This only has username and password, and then submit, input type submit, value sign up, value log in. Okay, now in index we say app.static or use, can't quite remember, express.static, yeah, here we go, then static. Okay, so we have our sign up and our login. We can type in username Sam, password confirmation Sam, hit sign up, and we've got a 500. Your JSON was stored into window JSON. We've got a 500. So, post to localhost 3000 sign up. Username, password confirmation. Somehow, we've got a 500, but nothing actually went wrong in here. So, post sign up. Okay, send error. JSON.error. What's happened? Let's just chuck a message in there. Okay, so it is going wrong here. What's the error? If error console.error error data and salt arguments required. Okay, so we've got salt, request body, password. Have I spelt something wrong? Password, request body, password. Request.body is empty. Oh, I know. Okay. I know, but I don't quite know how to fix it. Okay, so if we look at the request, we can see it is it looks nice. It looks like key value pairs. It looks like an object. But if we view source, it's actually a string of query parameters. The request headers content type, application, form URL encoded. So we want to send this as JSON, which is, let's see if we can not use JSON. Dot URL encoded. What? Okay, great, that worked. So by changing JSON to URL encoded, our Express app is automatically converting URL encoded kind of default form data into JSON for us. So, or into JavaScript objects for us. So we've just signed up with Sam. If username already exists, okay, so we're not actually checking that anymore. Request body, we can do Sam and Sam2. Oops, your passwords must match. So that's working. Okay, this is all a little bit weird, but that has not created a user. So we just have 3 Sams. Yeah, that's not great. But our sign up with our form actually works pretty well. And what we could do, we could redirect the user just back to this home page, but never mind. Okay, so let's try login. Sam and Sam, login, wrong password. That's a bit of a misnomer, because there is a Sam in there with the password as Sam, but actually we're finding the first instance of a Sam, and therefore this one I think was Sam1. So Sam1. Okay, great. We have a data breach exposed your password. Chrome recommends changing your password on localhost 3000 now. But we have received username Sam back. We have logged in successfully, and therefore we can continue going about our business on this website. So that all works. I'm gonna maybe delete some of these, and I'm gonna sign up with Facile. Okay, that worked. And me. Okay, so we have 3 different users now. Ooh. All right. So we have a front end. The problem is now every time we go to this website, we need to type in our password and hit login. Okay, it's redirecting us, but every time we come back to this page, we have to hit login and we have to type in our username and password. We don't want to do that because we're lazy users. So for that, we're going to use tokens. Now, tokens, they're a little bit like those hashes that we're storing, that we're using to store our secure passwords. They contain encrypted data in a string. So this is the kind of process that we're going to go through. The front end logs in, the back end generates and sends a token, and then the front end stores that token, and the user kind of keeps using that website. They leave the website, and then the user returns back to the website, and the front end retrieves the token from wherever they've stored it and sends it on to the back end to say, hey, can this user stay logged in, or do we have to kick them out, or are they a real user? So the back end receives that token, it verifies that it is a real user, that the token hasn't expired, and it sends the user data, or it could send an error depending on if the token was verified or not. So for this, we're going to use JSON Web Tokens, or short JWTs, or even shorter, a JOT. I don't like that. Or is it JIT? I think it's JOT, a JOT. Someone told me only quite recently that people refer to JWTs as JOTs, but I find that a bit too weird because it's not an O, is it? It's J. It's not how you spell it. Anyway, so a JWT, it's using a sort of standardized pattern and standardized encryption methods. And there are three parts to it. We've got a header, a payload, and a signature. It's quite similar to an HTTP request in that way. So the header has some information about the token. In fact, that's what the next three slides are about, so I won't really explain it here. But you can see the bottom line, or 3 lines, is a JWT. It is split into 3 parts, separated by full stops, by dots. So the first part is the header, the second part is the payload, and the third part is the signature. The header contains information about the token. So the algorithm used to encrypt that data, so in this case it's HS256, which is HMAC SHA 256. It's a slightly shortened version of a longer acronym. The type is JWT. So this, just like in your headers in your requests, you're telling the server what type of data you're sending. This is telling the server or the user's machine or whatever, it's telling it what type of token is being sent. In this case, this is a JWT. The payload, the second section, contains the encrypted data. This is really the important one. This is where the data that we want the user to store and send back to us, that's where it is going to be. So the data should be JSON, hence the name. It's JSON Web Token. It's a way to store and encrypt JSON. It is stored as a string. So here's an example: JSON stringify an object with a key of username that has a value of Franklin. So that could be the payload, and it gets encrypted into this blue section, and it's represented by a bunch of random characters. How exactly it gets encrypted is defined using that signature, the third section. So it uses the algorithm that is specified in the header. So that header said HS256, HMAC SHA256. So that's the algorithm it's using. It's combining the header and the payload with a secret key. So here I've just written my secret, my secret, my secret, my secret. That's not a very secret. It's not a very good secret key, but the longer the better. Someone could guess this. This is like a password, but it's kind of a password to unlock your entire server. So you want a super secure secret key that you store in your server's environment variables. You don't store on GitHub, and it uses it to generate these JSON web tokens. So it's pretty similar to bcrypt, to hashing. If this secret key changed every time, you might refer to that as a salt. But JWTs don't salt their data every time. It pretty much always stays the same. So here's how we use it. We install the JWT package, and it is not the only package out there. There are others. In fact, when I was kind of reading about this, I found another one that does look a little bit nicer than JWT. I think it's JSON Web Token. It's just a longer name. But I've used this package before, and it's pretty straightforward. So we require that JWT package. We create a token. We create a new jwt.webToken. So webToken is a class. Some of you haven't learned object-oriented programming yet. Some of you don't really know what a class is, but I think you've probably used the new keyword already, possibly, to create dates and things. But we create a new web token. We pass it a stringified payload, so that's our object that we want to store. And we also pass it the header. So this is why JWT is not a super nice library, because we always have to pass it this header. I would prefer if it always defaulted to this. If we didn't have to stringify these things, that would be nice. But it's not so bad. Token.serialize then creates the JWT from this web token instance. So we pass it this secret key, and that makes up those three parts. We have our payload, that's our important data that we want to store and send over to the user. We pass our header to the web token, and then we pass our secret key. In this case, I've written secret key, but actually it should be like this. It should be very long. So this is how we use it. So now we're going to create JWTs. We're going to send a JWT with our successful sign up or login responses. We're then going to store it on the front end, so we've got to write some JavaScript. We're going to do it a bit differently. And then we need a new route in our back end to authenticate that the JWT is a valid token and the user can remain logged in. It's 7:26. It's going to be a bit manic to get all this done, but never mind. We'll see how we get on. Okay, so npm install JWT. We then, I think, oh no, it's okay. I was tempted to make a separate file for JWTs, but what's gone on here? Is that okay? That doesn't look great, does it? Authentication, has it been added? No, it hasn't been added. Okay, I also realized published 8 years ago. Last published 8 years ago. Okay, I'm going to do a live change to what I'm going to use. I realise that JWT is massively out of date. JWT simple. Oh, I like the sound of that. JWT simple payload secret. JWT encode. Oh yeah, this is a good one. I like this one. Okay, so we're going to use JWT simple. This is much more familiar to me. So I've mostly done this using Ruby on Rails servers rather than Node servers, and this is very similar to how Ruby on Rails does it. So we want JWT from JWT simple. Acquire JWT simple. Then let's just console log jwt.encode. We have a payload which is username Sam. We have a key of my secret key, and the algorithm, you can see by this question mark, is actually optional. So we're just by default probably going to use SHA-256, something like that. Yeah, exactly. And then, but we can specify different ones if we want to. So let's run nodemon. Okay, so here is a JWT. They're very recognizable. They have these three sections with dots in between. They, for some reason, I don't really know why, they often start with EY, or they sort of start with, these two sections start with similar things. So if we keep running this, it's the same. That JWT is the same every single time. So it is different to bcrypt in that JWTs are standardized, and this secret key, that's the kind of important bit. As soon as that changes, then the JWT data is going to change. This header remains the same. This also remains the same, but this last section is different because my secret key that's been used to encrypt it all is now different from the previous time. Okay. So in here, if we want to, let's just do it in login for now. So what I'm going to do, I'm going to have a user object and then a token. We're going to say jwt.encode our user and the key secret key. So secret key should be defined somewhere else that is hard to access. My secret key, random stuff is good. So now when we log in, wrong password. Great. So we've logged in as Mimi. I clearly did Sam wrong. Did I even do Sam? Probably. Now we have the token. So we are sending the token back to the user when there is a successful login. Next, we want to take this token, send it from our front end, and in the back end authenticate that it is a valid user. So what we're going to do, we're going to send a fetch request to /authenticate. We're going to post. We can have token. We can say, we'll just paste in this token. And we're going to get a 404 for now, but that's the request that we're going to send to our server. So come down here, app.post, authenticate. We have our request and our response. We get the token from the request.body.token. Then jwt.decode. Decode, we pass it the token and the same key. So secret key that only exists on this server. Result is going to be, in fact, our payload. So let's run that again. It doesn't like it. No token supplied. Request.body.token. Oh, because I am. Can I use both JSON and URL encoded at the same time? Yes, I can. Great. Or at least maybe I can't, but this is last, so it's gonna, yeah, let's try that. Let's swap them round. Okay, it does work, so we can then just have both running. So we have encoded the user object into the JWT. Our front end has received the token, and then it's sending it back to the authenticate method. The authenticate method has called decode, and the result is that user object. So it's actually the payload. Decoding the JWT gives us the payload that we used in the first place. So if the user in DB, we could do db.get user.username. Then if no user in DB, response.status 54445, I don't know, send, or let's send JSON message invalid token. Let's return there. Then down here, that means that there was a user in the database that matches the username stored in the JWT. Then we can response.status 202 or whatever it was, 203 I think, something like that, .json, and we can send our user, obviously user in DB, we don't really want to do that, so user, we can actually encode a new token, user in DB, so we don't want to send the password hash, just like in here we don't want to send the password hash. So let's go back to the start. So Mimi and Mimi. We log in. This time we get the user object without the password hash. Then we're going to take this token, paste it in here, use this new token. We fetch, we send our request to authenticate. That's not what I wanted. And we have received a new token and our user object back. So authenticate is all working. Now we just need to hook up this page to use that token to prevent our users from logging in every single time. So for that, we're going to need a bit of JavaScript. Index.js. We're going to have script source index.js, and we're going to have the sign off and login form, but they're pretty much the same. So forms is document query selector all forms, forms.forEach form, form.add event listener submit. We receive an event. We say event.prevent default. We don't want to send that post request to action. We are going to do that, but we're going to do it using JSON. We're going to do it in the JavaScript. So we can have URL is form.action. Is that going to work? Form.action. So that's a form. $1 action. Great, that does work. Then we have a method. Method is post. Great. Method. They're both post, but you want to be as sort of dynamic as possible. So we're going to take them from whatever's defined on the form on these attributes. And then data to send is form.elements. Let's see what we can get. $0.elements. Username, password confirmation, password confirmation, submit. We can't really do anything sneaky. Suppose we could do that name. Yeah, let's do something fun. Form elements. Okay, so that is not an array. So we're going to spread it out into an array. $0 Okay, so we now have an array. We actually only want the first few, so slice returns a section of the array. We're going to take 0 and then form elements length -1. Let's double check that. Slice 0, 4 - 1, 3. Okay, gives us those because we don't want the input. Then we can reduce. I know that's everyone's favorite array method. Input field. And I'm going to format it. So our initial object is going to be an empty object. We're going to return the object every time, but we're also going to dynamically add input field dot name. So we've got username, password, and password confirmation, or just username and password, equals input field dot value. So that should generate our data to send. Now we can just use fetch URL method is that method, headers, content type, application JSON, accept application JSON, and body is JSON.stringify that data to send that we just generated. Well, let's see if that works. I'll be very surprised if it does. Okay. Have we even loaded up our index file? Yes, we have. So forms. Excellent. Query select all forms. Forms is a node list with 2 elements in it. They should have event listeners. Yeah, we've got submit on here, and hopefully Mimi log in. We have, I don't know why it's the wrong way. That's quite annoying. Time. Yeah, maybe. Time. But that's, oh, waterfall. Localhost. Okay, great. And it worked. So I'm going to do it again. We see a new login, password, and username. These are always going to be visible in your browser and your request payload, but the response comes back successfully with a user object and a token. We then say then response.json, then data, if data.token, there may not always be a token, local storage.token equals data.token. So Mimi login. We should now have in our application local storage, we have a token stored in local storage. So every time we load the page, local storage.token, we have access to that token. So finally we get to our localhost 3000 authenticate. We have headers, all of this nonsense. So method is post, headers is that, stringify, token is local storage.token, and then response.json, then data, document.body.innerHTML equals welcome back data.user.username. Okay, so there's quite a lot going on there, but we reload the page, and not immediately because we make the request pretty much immediately, but the request, in fact, we can see how long it takes here it takes 2 milliseconds, which is long enough for the page to render and then execute the JavaScript and then switch out the content of the inner HTML of the page. So sometimes, like LinkedIn, for example, LinkedIn does it quite nicely. LinkedIn, there's this little loader, then there's this, then there's this, then, so it's a pretty nice user experience to kind of slowly make all the requests you need and build up the page once you have all of the data. Did someone just unmute themselves to say something, or am I hearing things? Yeah, I thought I would be hearing things. So what time is it? 48. That's pretty much it. I think authenticate. Oh, we could do signing out. Welcome back. Button, sign out. Document.body.add event listener click. The bit weird. Oh yeah, let's do it really weird. If event.target.inner HTML is sign out, then window local storage, or just local storage.token equals undefined. So we want to remove token from local storage, and we could do window.location.reload just to reload the page, so they no longer see this message and they actually see the forms again. So welcome back, Mimi, sign out, and now we are seeing these forms. Yeah, this is what I wanted to do. I now need to handle this error. So authenticate, not enough or too many segments. That's basically saying something's gone wrong. You're giving me something that isn't really a JWT. Token here is undefined. That's not a JWT. So a couple of things. If local storage.token, then do all of this. That's the first thing. But it does look like there is something stored as undefined, and you always want to handle errors anyway. So if response is okay, then return response JSON, else throw response, or throw just like whatever. Then we catch it at the bottom. And what are we doing? We're authenticate. Then actually we want to log the user out. So maybe they do have a token in their local storage, but the server is saying that's no longer a valid token. Maybe it's expired. So when we're doing all our validation in the server, that can check the time it was generated, and you can include that in the payload if you want. But here we're just saying, okay, if there is a token, then we're going to try to authenticate. If it was okay, then we'll go ahead and convert the JSON and update the page. Otherwise, let's throw an error, let's catch it, and let's essentially log them out and remove that token because it's no longer valid. Yeah, it's not really doing that. I when I wrote token equals undefined, I knew there was something up. So we actually want to call remove item token. You can't just set something to undefined. Wishful thinking. So now we're reloading the page. We're actually not seeing anything in here. We're not seeing any requests to authenticate. If we say me, we log in. Okay, here we should do this again. We should handle login. This should be a function, but don't worry about that. We reload, we get logged in automatically. If we go here, if we change the JWT for something that's no longer valid, we reload and there. Huh. Why is there no request to authenticate? I'm confused about that. Token, something. We reload. Okay, so authenticate was actually coming back. Oh yeah, because we reload. So if we preserve the log, so let's add the token back, token. Reload, we see there is a request to authenticate. It's actually a 500. I think I sort of set that to a 500. It probably shouldn't be a 500, but there is a 500. We then clear the localhost, clear the token from local storage, and then reload the page, and that's why we weren't seeing that request, because it makes a whole new set of requests. Okay, that's pretty much it. So to add this to your kind of existing projects, your existing servers, it shouldn't be too complicated to add. What you then do is with your users, you kind of need to decide what you're going to send back to the user on the front end. You're going to include all their tweets, you're going to include all their friends, all their recipes or whatever. And this is how you can make sure that your users are getting the data that they should be. Okay, any questions on anything to do with authentication? Just check, store in front end, post authenticate. Yes, we covered all of that. So those of you who haven't got onto front end requests and promises and things, the stuff in the front end, a lot of it will have gone over your head a little bit. So don't worry, just worry about the back end for now and how the server is storing the data, hashing it securely, and sending tokens back and forth.
Sam, I have a question. So, do we use in real world local host? Sorry, local storage.
Yeah. Some people sort of say that they don't like it, but I don't see a problem with it. Some people seem to say that it's insecure, but I think if you're storing anything on the user's computer, it doesn't really matter. It's always going to be insecure in some ways. Local storage makes it just easier than cookies, really. But yeah, there's nothing wrong with using local storage.
So there's anything else rather than using local storage?
Is there anything else other than So if you want to store something on the user's computer, is there any other option? Is that what you're asking?
Yes.
Okay. So yeah, you can use cookies. So we all know about cookies because of those annoying little pop-ups. And your server can kind of set the cookies on the user's machine, and it doesn't rely on the front end setting stuff in local storage. But cookies kind of have a bit of a bad reputation because they've been misused, because the server in the headers can set the cookies. It just feels a little bit less kind of secure in a way. But almost every site you visit will be using cookies. But these days, probably almost every site you visit will be using local storage as well. You could argue that cookies are actually more appropriate for storing the JWT because they are automatically included in your requests. So any subsequent requests that you make as a logged in user on this website, you should include the token. Just with every request, you're posting a tweet, so you include your token to say, yes, I am this user, I am a valid user, and I've entered my password within the last 2 weeks. So generally that's included in the headers, but you can include it in the cookies that just automatically get included. So we have a cookie here.
Yeah. So when you go to application and when you check cookie, we can see the cookies.
Yeah, exactly. So these are Google Analytics cookies that have been stored on my machine when I was adding Google Analytics into a site that was running at localhost 3000.
But it's not the one you show me before that. You show me the cookies, but there is no cookies in here.
What do you mean? Sorry.
If you go back to the console, there is a cookies here. Oh, is it the same?
Yeah, exactly. It's the same. So GA equals GA 1.1, GAP, GA28, GA28, GAP, GA. So these cookies that are being stored inside your browser, the browser automatically includes them with every request that you make. So that's one argument for including a token in the cookies, because then for all of your requests, what you do have to do is I don't know, let's say post tweet, and we fetch to tweets, and we post, and in our headers, often what you might have is something like authorization, and that's your token, local storage.token, or just token, or kind of something a bit more complicated like XCSRF token, or there's all sorts of, it depends on the server really, it depends on what the server is expecting, but there are a bunch of different ways that you include your token in any requests that you make, but if it's stored as a cookie, you don't have to include it specifically in your requests. So it's one argument for using cookies. But I like local storage. It just makes everything really nice and easy. And if everything's being stored in local storage, it's just a bit, it's consistent as well, which is actually a big bonus.
Thank you.
Okay, no more questions. Then I will